Now the next concept that we have to learn is about the ring opening electrocyclization. So far what we have been doing is we were creating the ring, that is at the expenses of the pi bonds we were forming the sigma bonds in our systems. That was the driving force behind that reactions. Now what we are gonna do is from the sigma bonds we are gonna form is the pi bonds. Why is it so? Because the rings that we are having, there is a strain present in them. So as compared to the sigma bonds to be present in the strain system, it is beneficial to have it in the form of the pi bonds only, because the strain present in this ring is gonna create the instability in our systems. Okay, so uh, this is the role of this ring opening, that is the reverse direction. Now we are going to release the strain of the system. We are gonna do such type of the reactions to release the strain of the system. Such type of the reactions are generally observed. So here how is the reaction gonna proceed? So now you can see a four-membered ring is there. We know that there is angle strain present in this because each of the S center is your sp3 center, sp3 hybridized. It should have a bond angle of 109 degrees 28 minutes, but in the cyclic form it is having a bond angle of the 90 degrees, which makes it to be the strain because the deviation is there from the bond angle. Along with that, now double bond is also present in the ring, which makes the bond angle around these carbon atoms to be around 120 degrees. So again, the more deviation we are getting in the system. Okay, so we have to somehow release this type of the strain. So for that, what we go is in the reverse direction. Now we are going breaking the sigma bond, which was expected to be formed by the electrocyclization. Now this bond opening and this pi electron density is shifted. So here now you are gonna get is this four-membered open chain we are gonna get, that is from the cyclic form. Now we are going to the acyclic form to release the strain in the system. To release the strain in the system. Okay, so this is how the opening is being done. Now the next question based upon the ring opening is this one. Again you can see a four-membered ring with the double bond. So now this sigma bond is gonna break and this pi electron density will be shifted in the presence of the heat and the light conditions. So this product you are gonna get here, these double bonds will be present, right? Now the next is, suppose you have this question again. Now here this sigma bond is there, which will be opening and this pi bond will be shifted. So we are gonna get here is this type of the system where the double bond is being formed at this side and this side. Okay, now the next question is, you have this one again. Now here the strain is there, so this sigma bond will be breaking and this electron density will be shifted. We are gonna get here is this type of the arrangement. Here the pi bond will be there, here the pi bond, and this pi bond will be there. So this is gonna be your final product. Next is the heating conditions have been provided. Further again, the electrocyclic ring closing reactions are also possible, because once the strain has been released, the system is there with us on which the further reactions of the electrocyclic reactions we can carry it out. Okay, now the next is, you have this type of the system. So this was the one of the types where the four-membered ring only you are having this in which the strain is present. Further the ring openings you just have to do and you are gonna good to go for the product formation. So further you can represent it. Here you have 1 2 3 4 5 6 7 and the 8-membered ring you are getting. 8-membered ring we are having at one of the side. In between 1 and 2 you are having is the E conformation, because one bond is going in this direction, other one is in this direction. So higher priority groups are in the opposite direction. So we have to make the arrangements in such a way that this double bond is formed at the site where it is going in the E conformation it is having around it. So in this fashion we are not gonna observe this type of the reactions. So here is this 8-membered ring we have to form. So main thing is further the heating condition is there. So further heating conditions, again the electrocyclic reactions are possible. So if you consider this 1, 2 and 3 pi bonds to be in the conjugation, so again this pi bond electron density can be shifted, and in between your 2 carbon and this carbon number 5 that we have labeled, the bond formation is gonna occur. So this is gonna form the 1 dash, 2 dash, 3, 4, 5 and the 6-membered ring will be there. So 6-membered ring with the 1, 2 and the 3, this 1 carbon, 2 carbon and the 3 carbons will be in the in between. So main thing is, let me just take this again.